It's my pleasure to introduce Dr. Yingxue Tian. She comes to us from Rice University. She worked with Simon Fisher and she's graduate of the Department of Cognitive and Affective Neuroscience. And she has expertise and training in statistics and individual differences. And today she'll be talking about continuation of her work, focusing on serial order, working memory deficits, and relationship to language production.
Thank you for the introduction, Erica, and for everyone who's here and for all the Zoom. So today I will be talking about serial order in working memory and language production. And today's Shrier family topic in the rehabilitation science lecture is supported by a generous gift from Nancy and Marc Shrier. We're grateful for their support and belief in our mission. And here is this workshop offers a 1 AMA category 1 CME credit, and the code is 20 DRAM, 20DRAM. You can log on to the ebds.com to claim this credit. I was told to stop here a little bit, so if you can get it. All right, one last chance, 20DRAM. All right, we're moving on. So the planning committee member and the presenter has no financial relationships to disclose. And today we have 3 learning objectives. We're gonna understand the selectivity of serial order processing for different contents. And the second one is to understand the relationship of serial order mechanism in working memory and language production. And the last one is to understand the interplay of spatial cognition and serial order processing in working memory and potential implication to clinical investigation. So what do I mean by serial order? I want to start with several examples. When we're trying to remember someone's phone number, only remembering the digits in the number is not enough. We need to be able to remember them in the correct order to be able to call the correct person. Or when we're learning a new word, only having the speech sound ready is not enough, because ordering them in different order can lead us to produce different words like chicken versus kitchen. Or when we're learning a new dance routine, only knowing what the exact steps are, but putting them in the wrong order is not gonna help us avoid dancing out of sync with the rest of our group. So needless to say, serial order is important in our daily life. And today I want to talk about serial order processing, centering the verbal content, the one that's related to our language. I wanted to start off by talking about the well-known dissociation in working memory. So working memory is our capacity to keep track, to temporarily keep track of, maintain and manipulate information for subsequent goal-oriented behavior. So when we test this in the lab, immediate serial recall is commonly used, where you see or hear a list of information, and then you are asked to recall them in the same presented order. And this task can be given with letters or spatial locations. And dissociations has been found when this task has been given with different materials. Here's one example with participants with aphasia, that patient PV is impaired at recalling letter sequence, but is well behaved in recalling spatial sequence, and patient ELD showed the opposite pattern. This gave us a double dissociation that we're having separable working memory capacities to maintain verbal and spatial information. But I want to zoom in a little bit at patient PV. Why is she bad at recalling letter sequences? Is it because the task is immediate serial recall? So she was bad at recalling all the letters in the correct order as presented. Was she bad because she cannot report what letters she's seen, or is that because she cannot put them in the correct sequential format? So is it possible that people with the same impaired performance in immediate serial recall have actually different underlying deficits in their working memory? The answer is yes. So in the lab, we also have the dedicated effort to try to dissociate the item and serial order information. And this is, after showing participants a list, you can either give them a recognition task of, have you seen this letter before? This would help you focus on the item information, or you give them the order probe task at the bottom here, which asks them the relative order of 2 items, which could help them focus on the serial position of the information you just saw. So people have reported a lot of dissociation on this regard as well. And here's one example of recent work based on people with aphasia that two patients show the opposite pattern of being good at one aspect but impaired at the other, or vice versa, and offered a strong evidence of this dissociation of item and order in working memory. And today we're going to talk about this very specific circle here, the verbal small order working memory capacity. And I'm going to talk about three parts regarding the verbal serial order working memory capacity. The first is we're using the same serial order system for verbal and visual spatial materials to keep track of serial order information. And the second is what's its relationship to language production. And in the end, I will talk about some clinical implications on this topic. So we have seen the stuff on the left. There's an item and order dissociation in the verbal working memory domain. The same dissociation has been observed with spatial neglect patients in the spatial domain as well. So we have separate capacity to keep track of item information and serial order information in working memory in both domains. But we use the same working memory capacity to keep track of serial order in these different domains. It makes sense that just like item capacities, we have separable working memory capacities to keep track of this information for different contents. But on the other hand, what really are we doing when we're doing serial ordering? We're just putting items into slots, right? So this could be a general process that shares across verbal and spatial domains. So one of the challenges with domain generality studies is that it is really hard to match task difficulties between domains. Between some people are good at verbal tasks, some people are better at spatial tasks, and it's also really hard to dissociate item and order capacities. Because when you're recalling serial order, you kind of have to rely on your capacity of knowing what the item is before you put it in the right slot. So the approach I've been using is to rely on individual difference, which relies on, instead of the absolute level of how well one performs in this versus the other, we rely on the covariation between tasks. If this person is bad at processing serial order for verbal materials, is this person also bad at processing item information? Or is this person also bad at processing serial order information for spatial sequences? So looking at the covariation, we did sequence matching task with 153 healthy participants. So this task is pretty simple. Participants just see two sequences and have to judge whether they were identical or not. But we did manipulation in the trial type that sometimes the second sequence would have a new item inserted in any serial position, like the middle panel here, or sometimes the second sequence would have two items swapping their position. So this taps into the item and order aspects without really giving an explicit requirement for the task. So all participants know is I'm performing a task of comparing two lists. And we used verbal materials and visual spatial materials to test their capacity in different domains. And so what we did is directly pitting against these two hypotheses of whether serial order processing is domain specific or domain general with structural equation modeling. And then, so the model on the left with domain specific structures provided better fit for the data we collected, meaning that when people are performing serial order tasks, they have domain specific sources of the variance in their performance. So this answers our first question. No, we're not using the same serial order system to keep track of this information for verbal and visual spatial working memory. So how do we keep track of serial order then? One mechanism is language production. And I'm going to switch gear a little bit and talk about our work on participants with aphasia in this part of the talk. So in an immediate serial recall task in working memory, we get items and orders correct. That's important for the working memory performance. And it's actually the same with language production. We need to organize words in the correct order during output to convey our message. And in language production, we actually also deal with this at a different level. As I sort of used this example before, when we have a set of speech sounds, phonemes, getting the phonemes in different order in speech leads to different words. Kitchen, word chicken, word kitchen. So do we use the same serial order system to organize information in verbal working memory and language production? This is actually, this is not a new topic of the relationship between language production and verbal working memory. So that in almost all working memory models or language production models, there's a non-negligible link between working memory and language production. And as I illustrated earlier, there's actually a dissociation in working memory capacity to maintain item information versus serial order information. So the question I'm trying to look at here is, are we using the same serial order system for verbal working memory and language production, knowing that there's a close link between these two cognitive processes? This is not a new question either. Dr. Mary Ellen McDonald at Wisconsin Medicine has published a series of work on this topic. And my advisor, Simon Fisher-Bob, also did a lot of work studying healthy participants with their performance in working memory, in the serial recall, reading, and spelling, and found there's a shared representation of how we represent serial order for all of these cognitive processes. And the question I'm trying to answer here is actually at a slightly different angle, because what all the work before is about representation, about the processing mechanism, about the computing principles of serial order. And with neuropsychological approach, we can answer a even stronger question is there a shared serial order system, cognitive system, or neurosubstrate system supporting the serial order process for verbal working memory and language production? So this is one of the early work I did where we used the multiple case approach with 3 participants with aphasia, and we included them in the study based on their impaired verbal working memory performance, which is measured by the digit span task. Participants see or hear a list of digits and recall them in the same order as presented. And so the first step, hopefully I have convinced you that when we're testing participants with immediate serial recall, we're testing both item and serial order aspects of their working memory performance. So the first step we had with this group of 3 participants is to try to make sure they have serial order impairment in verbal working memory. So we used several tasks to isolate the serial order aspects of working memory. The first one is serial reconstruction, where it's in the recall format, but unlike the classic immediate serial recall, we give participants all the items they need during the recall. So all they need to do is organize the available items. And then we also have recognition type of tasks, the item probe and order probe, as I mentioned earlier, to tap into the item identity and serial order of the memorandum. So what we found is that the box represents the 10 healthy, age-matched, education-matched controls, and the colored ones are the participants with aphasia I was talking about. And I want to highlight one participant with aphasia. The one, it's really small, but it's in the green diamond. So patient MB showed impaired serial order performance in both the recall and recognition type of tasks, convergently suggesting that he, within his impaired working memory performance, he has impaired serial order performance in verbal working memory, while the other 2 patients were within the control range. And then we went on to test their production ability. So we did repetition tasks, and we also did spelling, but I'm not gonna, I want to stick with the spoken part for today's sake. So we did the repetition task to analyze these 3 participants with aphasia production performance. And what we found before was that we have one patient, MB, with impaired verbal serial order working memory capacity. And we have 2 participants with aphasia, EV and SH, who were preserved in their serial order front in working memory. So if the serial order system is shared between working memory and language production, then MB would show prevalent ordering problems during production, while the other 2 patients should not show ordering problems during production. But if these 2 systems the serial order systems are separate for verbal working memory and language production, then we wouldn't have any specific expectation for what error types might occur in production. And here are some actual examples that patient MB made during repetition task. I'm going to play some sound, which is hopefully it works.
Committee.
McKitty?
Umbrella.
Umbrella?
River.
Liver?
So what we did is from all of this speech errors, we trace the source of why this is an error into item or order error. So for the first two, it was a sound that's produced in a different serial position, but from the target. But in the last one, the sound the was not from the target, so it was an item error during production. And so we use this order error percentage as a measure to characterize the prevalence of ordering error during production. And if you take a look at the example here, in umbrella, the sound the was categorized as an order error because it was from the target but produced at an earlier serial position. But in river, the sound the was just randomly produced and it was an item error. So to control for that randomness in the categorization of an order error, we also did simulation for what the order error percentage might be based on chance, just produced by chance for each participant to gauge whether they have an actual reliable significant serial order deficit in production or not. So this is our result. So we have a patient MB with impaired verbal serial order working memory and two other patients without that. And all the vertical bars are the actual observed order error percentage, the actual prevalence of order error they made during production. And the blue histogram is the chance distribution of the order error, what order error percentage might look like if they're just producing these by randomly. And what we found is associated with his serial order impairment in verbal working memory, MB also showed impaired, also made significantly prevalent order errors during spoken production, while the other two patients were preserved in both verbal working memory and language production. So this associated impairment or preserved performance of serial order suggested that serial order system is shared in verbal working memory and repetition from our sample of 3 participants with aphasia. And then at the MRI, we further went to see, explore this relationship a little bit more, because we know production actually have different stages. In naming, when you see an image, you need to retrieve the semantic information and then map onto the word form, and then map onto the phonological representation, and then later for production. But in repetition, you actually only went through the second stage. You're provided with a word form already, and then you map onto the phonological representation to produce it. So what the study I just talked about actually covers mainly the second stage here, suggesting that the serial order system is shared between verbal working memory and this process of mapping from word form to phonological representation. And here, now I'm going to talk about our recent work here, where we extend what we find from 3 participants to 30 participants with aphasia, and also extending from repetition to a more complex production process, the naming process. So with a larger sample, we would gain more power and have more gradient serial order performance in production to be able to corroborate what we find before with our sample of 3. So the tasks we use are naming tasks and repetition tasks. And we selected only phonological errorful responses in the production, which are semantically unrelated non-word, like harmonica into a monitor, or semantically unrelated word, like compass to pocket, or some constitute of the word might be preserved, but there's still phonological mismatch in the response, like the last one, waterfall into waterfall. So within the phonological errorful responses, we have, like the study before, we categorize the source of the error being item error or order error. And for each word, we have this order error percentage of, like, what's the prevalence of ordering problems for this word. And the final measure we get for each word is this effect size-like measure, where it captures the impairment, the severity of the serial order impairment. So the observed value is the green bar, and the simulated chance for each word is this histogram. And this effect size measure is how far our observed value from the serial order error percentage being produced by chance on average. So the larger value it is, meaning the more impaired this, the less likely the serial order error made in this word is made by chance. So the more impaired serial order processing is during production. And also in this project with 30 participants, we try to make it more generalized, provide more feasible options for future work. So instead of applying for specific serial order targeted working memory tasks, we used already commonly used easily accessible tasks in lab, which is immediate serial recall, and we use the serial recall of words and pictures with verbal and manual response. And for each response in working memory, we have 2 sets of measures. We judged whether this response was a correct item or a correct item at correct serial position. And with that, our item working memory measure for each person is the overall correct item being recalled out of our response for this person. And our serial order working memory measure is the correct item being recalled at the correct serial position subtracted by the item performance. So this would be a negative value, but like a larger or less negative it is, the better this person is at maintaining serial order in working memory as well. And then we did it because it's both verbal and manual response, and we did a composite score so that our characterization of working memory performance wouldn't be too limited by the output process, by the verbal output process by participants with aphasia. So here's a messy look of what we actually got from item and working memory measures in this task. And we can see there's a pretty decent amount of variability of people's performance in item and order. And here's the final result of what we got. Together, we try to see what's the relationship between serial order process in verbal working memory and their serial order impairment in production. And here's the simple slopes from our mixed effect model. And the y-axis is the effect size measure in production. So the larger value it is, the more severe, the worse serial order processing this person have in production. And the x-axis is working memory capacity, which the lower value it is, meaning the lower working memory capacity there is. And in repetition, the figure on the left, we have found that worse, only serial order working memory capacity significantly predict the serial order processing deficit in repetition. So the worse a person have with serial order working memory capacity, the worse that person's performance is in terms of serial ordering in repetition. This replicated what we found before with the 3 participants with aphasia, suggesting that the serial order system is shared between repetition and verbal working memory. And the figure on the right is the naming performance. And in this one, we did not find a significant relationship between serial order working memory and serial order performance in naming. But on the other hand, we find that the worse a person have in terms of keeping track of item information in verbal working memory, the worse this person is at processing serial order in naming. So this suggests that we do not, the serial order system do not share do not share with verbal working memory and naming when it's actually only one extra stage we employed during the production process. That as long as you have the idea of retrieving from semantic to map onto word to map onto phonological representation, as long as this process happens, it's no longer a simple shared performance of just verbal working memory, but instead there's more reliance on long-term memory, and also working memory buffer is needed. That's why the item working memory capacity is an indicator for serial order performance in naming. So now moving on to the last part of the clinical implication, and I want to talk a little bit about both restorative and compensatory mechanisms for based on what we know about serial order processing in working memory and language. So as we just talked for a while, the naming process have this two-stage process. You see a picture, you go through semantic word and to phonology and to produce a word. And there are there are a lot of naming treatments. And today I'm only going to talk about 2 types of them. The retrieval practice, where it's essentially a naming task. Patients would be presented with a picture and were asked to retrieve what's the name of this picture. So you have to go through this whole process. And the other treatment type I'm going to talk about is errorless learning, where the correct name for the image is provided. When you see a picture of pyramid, you would hear pyramid and you see the written form of pyramid. And the patients need to just repeat it and say it back, which goes through the mainly the second stage of this model. But as we sort of touched on in naming deficit, when you're bad at naming, you can be bad at naming for different reasons. It could be you don't know what exact sound you want to make, and that's why you're bad at naming the object. Or it could be you have all the correct sounds in your mind, but you have trouble sequencing them correctly to say the word right. So if there are different ways to be bad at naming, why would people with different reasons of naming impairment benefit similarly from different treatment types? Can we use the understanding of what their actual reasons of naming impairment to help us select what treatment plan to apply for this person? And if a person have item deficit in naming, then both treatment type going through all stages or just stage 1 may not make a difference. That because your exposure to the exact phonemes during output are essentially the same. But if this person have a serial order deficit in naming, meaning that you don't have problems selecting the phonemes, but you have problems sequencing them, then maybe errorless learning going through stage 2, giving you already all the phonemes you need, would help you practice more on sequencing the phonemes, kind of like the serial reconstruction task we did. We provide all the information, all the items that you need to recall, and all you need to do is reorganizing them. And maybe practicing like that, going through the errorless learning would help people with serial order deficit in naming to benefit more. So this is part of Erica's larger study in naming treatment, and we leverage the existing data set to take a look of this work. Oh, also this work is just some direction we're moving toward, and we would very appreciate any kind of feedback that's to brainstorm of what's a possible hypothesis to drive here. So anyway, back to the study. So in this naming treatment study, participants would have baseline assessment of their naming performance, and then going through treatment with retrieval practice or errorless learning. And then 1 day later, they will be tested with naming again. And what I want to show the data is on the testing part. It's on the testing part here. After the different treatment types, what's their naming performance is during test. And here is the red is the untreated items during test, and the green is items that's been through errorless learning treatment, and the blue ones are the items that's been through retrieval practice treatment. And the overlap here is the overlap between the target and the response during their production. So the higher value it is, the better the performance is. And here we can see we have a pretty significant group level effect that those treatments improved a lot compared to untreated items. But do everybody benefit from them the same? And when we take a closer look, I picked out the two really obvious ones that's embedded in the massive plots. But some people improved more with retrieval practice, and some people improved slightly better with errorless learning. And going back to our original idea, could that be driven by them having different item or serial order deficit in name to cause this differential treatment gain? And this is some preliminary result from us putting everything together in the mixed effect modeling. And again, the y-axis is how well they are. It's the overlap between target and response. So the higher value it is, the better the performance there is. And the x-axis is a little counterintuitive. It's a severity measure we've been talking about. That's the difference from their serial order impairment from their chance level performance. So the higher value it is, the more impaired this person is in serial order, and the lower value it is, the better serial order processing there is. So we can see the better serial order processing in naming baseline would predict better naming performance during test. And also this relationship is stronger with errorless learning than retrieval practice, suggesting that this could be a good start to index people with their baseline assessment to see to guide us into later treatment selection, since they would have different response in terms of how much improvement there is following treatment. And we're doing on time. Okay. So the last thing I want to talk about is like jump the gear a little bit. It's about a potential compensatory clinical implication of the serial order processing that we've been brainstorm about this on and off, but would really love to hear some feedback about like whether it is a feasible direction to move forward. So in this part, I'm going to talk about the serial order in verbal working memory and how it interacts with spatial processing. And I want to introduce this behavioral phenomena associated with serial order working memory called the Spork effect. So it is observed in many working memory paradigms, and here I'm using the example of an item probe task. So in this task, participants hear a list and respond with either their left hand or right hand. And the observation was made that when people's left hand is faster to their right hand when they're responding to earlier items in the sequence. And their right hand is faster than left hand when they're responding to later items in the sequence. So to put this more clearly in a figure, so if you subtract the reaction time between two hands and then plot it as a function of serial position, you can see this negative slope, suggesting the left hand advantage for earlier items and the right hand advantage for later items in working memory memoranda. And this significant negative slope confirms the observation we just talked about. So this hand by serial position interaction is then known as the Spork effect, which is the association between spatial and the position in the response code. It is quite a robust effect. that's observed with a lot of different working memory paradigms and with different verbalizable materials. And there is a hypothesis generated from this effect called the mental whiteboard hypothesis, which suggests that when we encounter information in working memory, we spatialize them, lay them out on the mental whiteboard as an actual whiteboard in your mind. And then based on your reading habits, so for a lot of us, it's from left to right. And when we search through this whiteboard, it's to retrieve information or maintain information or manipulate information in working memory. And then later when we respond, so when we do all of this manipulation on the whiteboard, we map the serial position of the verbal working memory information to the locations on the whiteboard. And therefore we have this advantage of different responding hands by proximity. So this hypothesis offers a great conceptual framework for why this happens. And it suggests that serial order processing is grounded in spatial processing, but it is somewhat vague about what spatial processing is. It could be spatial attention, how we orient our attention in space that's helping us to generate this, to better spatialize the verbal working memory information and generate this sport effect. Or it could be how well we keep track of spatial information in working memory to start with. The better you are at keep track of those information, the better you are of keeping track of the spatialized verbal working memory memoranda, and therefore having this effect. So I did this study as part of my dissertation to from the individual difference approach to see if the magnitude of the sport effect actually have any relationship with how well people are keeping track of their verbal serial order information. Do people with larger sport effect better at keep track of serial order information because they have this external help to keep track of that? Or do people with different spatial working memory processing capacities or spatial attention processing capacities have a better job at exhibiting the sport effect because they're so good with the spatial resource in cognition? So we did a battery of tasks, and then there are 3 spatial attention tasks. One is breadth of attention, where it's kind of like the useful field of view effect. It's basically characterized how wide you are, you can monitor the space without splitting your attention. And then we also have the classic post-nervous cueing paradigm to see how fast you orient your attention in space based on salient exogenous cues or endogenous cues to orient your attention with symbolic means. And we have working memory tasks that you've seen from the paradigm with sequence matching task to gauge the item and serial order working memory performance in verbal and spatial domains. And also we have 2 tasks to gauge their sport effect. So long story short, we put everything into a hierarchical mixed effect model. And what we found is that the spatial attention capacity does not predict how big the sport effect size is. But on the other hand, we do find this relationship between spatial working memory and the sport effect. And we sort of unveiled the mechanism of the sport effect in terms of working memory. So here's the simple slop of what we have. And then from left to right is verbal serial order working memory and spatial item and spatial serial order working memory. And from red to blue is the increase of the corresponding working memory capacity. And what we found is that higher verbal serial order working memory is associated with larger sport effect, which is indexed by a steeper slope here. And the higher, same thing with spatial item working memory. A higher spatial item working memory index a larger sport effect. So this suggests that the sport effect actually facilitates verbal serial order working memory. The larger you are, the more you are at spatialize your information, the larger sport effect you exhibit, the better serial order working memory this person tend to have. And on the other hand, this positive association with spatial item working memory also told us that the higher capacity this person is with keeping track of locations in working memory, the larger sport effect that this person have. And it's another story with how we keep track of zero order information in space, but yes.
I have a question. This is very interesting. So this sample is a healthy, uninjured neurotypical participants. I'm curious, like, whether the sport effect could possibly mean different things at different levels of performance, because if you have a big gap, like you could, because it's like a time lag of
Yeah,
in some ways. So I'm wondering if in people who have deficits in serial or precision, if you would see the same relationship, or if there might be, if it might have different interpretations in individuals who are impaired.
yeah, that's actually one of the challenges we were initially trying to adopt this into the population with aphasia, because it's a reaction time based effect. So so if they're already at, I would say like generally slow at responding to different things, maybe the difference at different zero positions are very subtle, then we wouldn't be able to see the slope. So that's one of the challenges we need to figure out how to do when we translate this.
So having the signal at all could be like a sign of intact functioning, almost, because you think that maybe the slow reaction time could wash out some of the sport effect potentially.
Yeah, potentially. Also, I think the sport effect is not it's an automatic mechanism we adopt following learning following reading proficiency. So this doesn't occur for children. The children has to reach it was a study done in France. So they have to reach second grade where they acquire the proficient reading and writing performance level, that this start to emerge. So this is more like a external facilitatory mechanism.
So
that
that's
could be-
true, because people don't show this group effect until they're good readers.
Yeah, until the reading become an automatic process. Yeah. So yes.
Does the left to right thing, does it flip for people that read in languages that go the other way?
This has not been done with the sport effect, but with the spatialization of numbers, of number magnitude, the snark effect. People have done this study with from right to left reading habits, and it does reverse for certain languages, but I'm gonna say, I think for Persian it reversed, but not for Hebrew.
Do you think that has to do because they tested numbers and our number system comes out of,
Because of the magnitude of it.
no, just we came out of it version.
Then I don't know. I think it's depends on how like for number it's a little bit different, right? For this for sport it's more rooted in the reading process. So how the direction of your reading really affects of like how your working memory functions somehow. But for number processing, maybe it's more abstract, that it's your reading habits from left to right, for right to left, but it doesn't affect you as much in terms of how I represent the magnitude of the numbers.
The long list of numbers from one side to the other.
So yes, it is the reading habit, the reading direction definitely changes. Not definitely, potentially could change the direction of how we use space to represent the information. So yeah, then we also collected some data at the neurological level because we want to see, like, we know that spatial working memory interacts with the sport effect and potentially with verbal zero order working memory process. So we want to see, do we establish this on the brain? So we collected some resting state fMRI data with a sample of 25 healthy participants, a subset of the earlier behavioral data I just talked about And then, so here we try to, the measure we're getting is how modularly these two function-specific network interacts. So how selectively or exclusively the verbal zero-order working memory, cortical regions and spatial attention cortical regions interact. At the, like exclusively within each other, but not with the rest of the functions at rest. So with this modularity measure, we get at this level of interaction between cortical regions. And what we found is that the exclusive interaction between verbal zero-order working memory and spatial attention network predicts the magnitude of the sport effect. And also corroborates with what we found behaviorally, that the spatial working memory, the cortical regions corresponding to spatial working memory function and verbal zero-order working memory, function, the way they interact also predict the more exclusively and intensively they interact within this function-specific network, the larger the sport effect size is. So this so all of this function-specific network predict the sport effect better than the whole brain network. So it's not just about how interactive this person's cortical regions are, how interactive you're using all of your functions together. It's not just about that. It has to be function specific. So in summary, we have found this sport effect, the spatial recoding mechanism supporting verbal zero-order working memory. And this spatial recoding mechanism is supported by spatial item working memory and from the behavioral data, and also spatial attention from the neurobiological data. So this is still correlational, like Amanda mentioned earlier. Like, does how big the sport effect size? If we train them to be bigger, can we improve the verbal zero-order working memory? So this has to be with the challenge in mind in population visualization. We may have to establish this proof of concept with healthy participants. And then when we translate into clinical work, we probably don't have to measure their sport effect because latency would be kind of hard to gauge. But instead, we know this treatment can improve the sport effect size. And then we want to see if this can help them improving their zero-order performance in verbal working memory. Also, a step further from that, can we see some transfer? Can we see some bar transfer? If we improve this person's verbal zero-order working memory capacity, can we see the improvement of zero-ordering in repetition, in reading, spelling, and vocabulary acquisition, which are found in the neurotypical population to be associated with verbal working memory as well. So with that, that's all the contents we mentioned today, and we have established that zero-order system is not shared between verbal and visual spatial in working domain in working memory, and we have established that verbal working memory and repetition shares a zero-ordering system, but not with naming. And there are some potential clinical implications of characterize the item or order impairment in production to potentially help us with treatment selection, and also maybe to see if we can use spatial recoding to improve the zero-order maintenance in working memory and see further transfer into other cognitive functions. And most importantly, I want to say this acknowledgement. I want to share my gratitude to all of my advisors, Simon Fisherbaum, Eric Middleton, and Marilisa Milland, and thank all of my collaborators and my MRI colleagues. Special shout out to Krista and Adeline for the help of the case series study that was, I was bugging you guys a lot, but thank you for bearing with me. And then thank all of my undergraduate research RAs from my dissertation work, and all the awesome participants for making this work happen and to make it meaningful. So to leave this up, so this is the CME credit 20 DRAM for today, and I think we have some time for questions.
Really interesting talk. I was a little unclear about the
your discussion of errorless learning for a restorative kind of treatment, in the sense that I thought one of the problems that people have when they have messed up serial order is that they make errors in their sequencing. So how do you achieve errorless learning through repetition if they can't accurately repeat, is the question.
I think one of the philosophy of the restorative treatment is, if you're impaired at this mechanism of action, you should keep practicing, just strengthening the connection of this. So I think I can't really, well, I can kind of sort of guess what the serial order representation is from repeating. But I think just through errorless learning, you're repeating all the phonemes in the sequence. So through that practice, you're just like
So you mean,
applying the mechanism.
but you wouldn't need to be repeating them in the correct sequence?
I think you would.
So that's the issue, is that errorless learning is easiest to implement when you have control over the behavior, but you don't have control over their articulators. So once they utter a misarticulated word, you're outside of errorless learning.
We have a model there, right? You could read it, you hear it, but you can read it. You could be refreshing the auditory form as a model and use that to program the sequence and output technology.
I guess the empirical question is,
Yeah.
can you get 0 or close to 0 errors in repetition with that?
Yeah.
Because if you can't, then the errorless learning mechanism, at least as I understand, it, wouldn't apply. You have to have some way to get them to do it right.
Mhm. Yeah, I mean, in our studies, we typically recruit people with good repetition. And, but we do have a couple studies where we actually, focus more in on phonological output problems. And it's those that actually do benefit from this, because the notion is, well, I guess, whatever that limitation is, it's not really possible. It gives them more practice.
Yeah,
for
I
the
mean,
behaviors that
whatever
they
you
need.
can do, if you can actually succeed in getting them to emit the right behavior, right, that's what I was not confident of.
I think one thing you can do is to just give them shorter words. Typically,
Excellent,
they
thank
are
you.
able.
I really like the idea of profiling the ability at baseline and then prescribing a different kind of learning according to that baseline. Must say you had a really interesting graph about something like this, the ability of baseline versus performance back in section 2. And I must say I didn't quite follow it, but the principle is good. But I'm just wondering, you had their ability at baseline gave them a better performance. Maybe you could go back to that slide if other people, I was right at the end of section 2. Because I was just curious, because you were saying you wanted some feedback on clinical directions and things, but it was, yeah, I think it was that one. So what is this? What is this better naming performance? What does that actually mean? That's responding to a particular. You try them. I guess you just profile them in naming.
I think it means, that's a greater benefit.
Greater benefit
From the training.
from the training.
Right?
Got it.
Enjoy why it means that they benefit, yeah.
So you would, in order to figure out how to make this clinically applicable, you would look at how they respond to a training or something like that, or?
Well, I think, so the interpretation here is that for the items trained with errorless learning, the people with better serial order ability benefited more. So that, I think that goes along with John's kind of question there. So they are getting a benefit if they have good serial order working memory processes, which does kind of make sense, because the advantage of errorless learning is on every trial, you have an ability to practice the production of the form, in contrast to retrieval practice, where on some trials you're not going to be successful retrieving it, and then you don't get that stage 2. So I think this pattern does make sense, but does it answer? But in general, though, the clinical implications of this, we're just starting to think
Yeah,
about,
yeah,
so we do
yeah.
want feedback about what you guys think.
I was wondering how much this generalizes. Because presumably if you're training something like serial work order, then
Yeah.
that should be generalized across, right? It shouldn't be word specific. So then you should see improved benefits on untrained work.
Yeah, that is one direction that we could explore to see, just compare to baseline, how the untrained one also improved, because we have
Yeah.
the performance for those words as well. This data specifically here, like I kind of should mention it more clear, is only with the retrieval practice and error disturbing
So
set.
this is only the trained, right?
Yeah, this is only the trained items during test.
One other, I mean, this is just, I guess, more of an intuition, but when I think about serial order and most of the ways that you test it, it's a quite a explicit and conscious thing. Certainly, I don't have that intuition about phonemes in a word. They go by so quickly and you sort of think of them as a chunk, but I guess your hypothesis is that even though they feel quite different, the underlying mechanism is sequencing those very fast bits the same way that it sequences big chunks of temporally related information.
Yeah, this is quite the fascinating part, that it actually cuts across the board to generate the phone level. It's surprising, but could also be not surprising in a way, because sequencing is quite fundamental to verbal performance. And there is a hypothesis that we have, because during evolution, we have this limited amount of cognitive primitives to support our functions. And serial order could be one of them, that we're using this archaic structure to that's sufficient enough to sequence the big chunks or the smaller chunks. Because in working memory, it's also hard to determine what is an item, right? Usually we do words.
You chunk things together,
yeah.
they become an item, yeah.
Yeah, we do like letters or digits, but then we do words. They're actually pretty different, and with all the meanings associated with them. So that's one of the take it with a grain of salt is when we do verbal working memory, we have to consider what's like the link to language and what the actual information is being there.
And I thought you showed an association between serial working order for phonemes and for items.
Was that they were correlated?
The one to sequence phonemes versus sequencing verbal working memory in repetition task, yes. So the performance are associated when you're organizing phonemes in repetition, and when you're organizing letters and words, I think, in working memory.
I think it is words, but in work.
Is it word? Yeah, I think.
Yeah, it's word span and picture span.
Yeah, in the larger study, we did word and pictures, so it would be at the word level. Yeah.
We want more feedback on the spark, the direction of the spark effect, and like what would training look like. I guess what I always kind of get confused about, like, for example, would you train with the spark paradigm, or is that I'm not sure, but you know, like what?
Yeah, so there were some studies to see how it's manipulatable. So you can ask people to mentally organize yourselves from left to right versus right to left. These are all for people's default reading directions, left to right. So by applying that instruction, they can actually test the transient spark effect being reversed. That's mapped from right to left. So I think it's a quite
So as a
manipulatable
compensatory measure, you tell them to think about a whiteboard and think about putting this on, like you would just kind of give them that
Yeah, I don't think
instruction.
you would do, this would be the index of whether you're teaching them succeeded in. But I think it would be like, yeah, let's organize this
Let's
information. How are you gonna
imagine
do
that,
it? Let's
yeah.
organize this. How would you do it?
Yeah.
Try to make those habitual
And if
tendencies.
you're gonna do it to help production though, like the whiteboard.
Yeah, I
you're-
know.
I don't know, you're generating a picture in the orthographic representations of it. I mean, because orthography is so variably
Right.
disordered in the page. That's where I keep hitting a wall there. Like, I don't know how it can be a useful compensatory strategy, except for people for whom orthography is really surprisingly intact in spite of their generalization, which there are some people like that, but then they would have to have a particular sequencing problem.
Yeah.
So I just don't know if it's too niche.
And
you know?
there was that strategy that, Myrna and, the engineer woman who came here
Oh,
for
Marcia.
Marcia Linebarger, where they assigned arbitrary tokens that could stand for words, so you didn't have to have orthography, but you have to be able to remember the red triangle is.
Yeah, and they could stand for chunks of sentences. too.
Yeah, so that you could have, and that was actually a whiteboard, so maybe something that actually involved a device that you lay stuff out in.
I mean, I would like to see that it reverses in people with, speak in other languages first.
That's important. If it's real.
But
then
that's
it kind
trained,
of
that's
has to be
training evidence in some kind.
Yeah.
If it's a real thing, it should happen.
I hate to cut this off, and it's run over time, and we have a meeting in this room, but that was a great.